Hi, this is another video, and this is the same problem as what we had before. Now, this problem is asking for the takeoff speed. It's asking for the takeoff speed, and we're going to solve this using only two given values or given quantities. Now, as you can see from the problem, we only have one given value or one given quantity explicitly given, but we have to take in mind or bear in our minds that we have another value that we have to consider, or another quantity given that is related to vertical motion. Okay, so first, identify the given. When you have a problem, always find the given. So, since this is a vertical motion, then objects in vertical motion are always acted upon by a certain force, that is gravity. And with that, since there's a force acting on an object in vertical motion, then that means to say the object will accelerate, and therefore it accelerates at 9.8 meter per second squared. This is acceleration due to gravity. And then another given is the distance along the y-axis. Remember the xy plane? This is the y-axis and this is the x-axis. Vertical distance, or the distance along y-axis, and that is 1.29 meters. Now, this is a much longer solution, but at least I'm going to be showing you what we have to do here. Now, we are asked for the takeoff speed, so we have to know and find out what is the initial velocity. What is the velocity of LeBron James for him to reach the vertical leap of 1.29 meters? Okay, what is this? Takeoff speed. We can also say takeoff velocity. Okay, now just bear in mind that speed and velocity are related. It's just that velocity is a speed with a direction. An illustration, you have to take note that at this certain point in time, LeBron James, or the object, or the leaper, has to stop or momentarily stop. Velocity would be 0. The final velocity here would be equal to the takeoff speed. Now, please do not be confused. We have here initial velocity and another initial velocity. Okay, this initial velocity here is for the red path from up here going down, and then this initial velocity here is for the blue path from down here going up. What formula are we going to use? We already had this given, this, and then to get for the final velocity, we can use this kinematic equation. Vf equals Vi plus At, acceleration due to gravity times t. But we do not know this. This is unknown yet. So we can use another equation that will make us find the value for time. Okay, we can use this equation. D equals VIT plus 1/2 AG t squared. Okay, and since we're going to follow the red path, okay, for the red path, the initial velocity is 0. Now let's assign values. We have 1.29 meters, and then 1/2 acceleration due to gravity value for that is 9.8 meters per second squared. And for the time, of course, this is our unknown in this formula. So let's solve. We have 1.29 meters. Going down there. Okay, now so let's substitute the value here. Now from the given, or we will just focus on the red path. The initial velocity will be 0, and then of course we know this is 9.8 meters per second squared, and we already have value for time, which is 0.51 seconds. So cancel this out and we calculate, and therefore we will get 4.998 meters per second. That's the final velocity. Now let's compare. Okay, we have here 5.03. Well, maybe because that is because of the exact amount that we took the square there, and this one we had to round this off, that's why we have it. But if we're going to really use the exact value for that, then we're going to get exactly the same as the previous answer. We have the here we used 0.51, but here look, I'm sorry, the exact value is there. I'll show you that. 1.29 divided by 4.9, then that's the total value. We get the square, and that is the total value for time, and then we just multiply 9.8, so times 9.8. There we get the exact value, and that is, we're going to use the exact value, then we will get 5.03 meters per second, and that is the final velocity. Again, they are just equal in magnitude. This is actually negative because this is a negative acceleration. The negative there only indicates the direction that this already moved from up going down, then that would have a negative direction. But the magnitude for this one, for this final velocity, would be equal to the takeoff speed, and that would be your takeoff speed, 5.03 meters per second. Okay, this is now the final answer, and we compare it with the first one. We have there the takeoff speed, which is 5.03, and then this one, they're just the same. And I hope you guys you learned. See you all next time for our other video calculate problems in physics. Thanks, see you.